There are more things in heaven and earth, Horatio, that are dreamt of in your philosophy. Welcome to the deep dive. You know that quote from Shakespeare? It just feels so right for today's topic, because we're talking about our own planet, Earth, and, well, secrets it's been holding on to, things we maybe didn't dream were possible. We're diving into unseen connections, hidden journeys deep beneath our feet. And the central idea today is pretty astonishing. Gold and other precious metals, things we thought were locked away forever deep in the Earth's core. Well, they might actually be leaking out, making their way up towards the surface. Sounds wild, right? It's this incredible journey from the Earth's very heart.
It really is a journey that challenges some fundamental ideas we've had for a long, long time.
So today we're digging into this. Our source is a, well, truly groundbreaking study just published in the journal Nature, which is a big deal in science.
Absolutely.
Our mission here is to unpack what this finding tells us about how our planet works internally, how it evolved, and how these vital elements, things crucial for modern tech, get distributed. And for those of you listening, maybe preparing for exams like the UPSC mains, this is really important stuff. It's cutting-edge current affairs and earth science. Definitely useful for prelims, too.
And honestly, even if you're not studying for exams, it's just fascinating insight into our planet.
Exactly. So let's get into it. This idea, material escaping the Earth's core, my first reaction is just, wow, how is that even possible? Gold leaking out.
It does sound counterintuitive, doesn't it? But that's the core finding. The research suggests materials from the Earth's core, and they specifically mention gold and ruthenium, which is another platinum group metal, seem to be slowly seeping into the mantle above.
Mantle, right, the layer above the core.
Exactly. And from there, somehow rising towards the surface. And they've actually observed evidence of this in specific places.
Where?
Primarily in active volcanic regions. The big example they focus on is Hawaii. Yeah. And this really opens up a whole new realm of possibilities, for understanding how Earth evolved and where these metals actually end up.
So how did scientists figure this out? I mean, the core is thousands of kilometers down. You can't exactly drill a hole and take a look.
No, definitely not. It's all about indirect evidence, really clever detective work. The findings, led by Dr. Nils Messling from the University of Göttingen, are based on really detailed chemical analyses.
Of what?
Of lava flows, specifically from Hawaii's volcanoes.
Ah, the volcanic connection again.
Precisely. They analyzed the lava and found these, distinct chemical signatures, tiny traces, but unmistakable. Signatures indicating the presence of metals like ruthenium and gold that really shouldn't be there in those concentrations, based on old models.
Shouldn't be there because?
Because the prevailing theory was that these heavy, iron-loving metals sunk to the core billions of years ago when the Earth first formed and differentiated. They were thought to be trapped down there, essentially forever.
Billions of years, wow.
Yeah. But this study suggests that volcanic activity, like in Hawaii, might be acting as a kind of elister, a route for these metals to travel upwards, carried along in the rising magma.
So the lava is bringing up souvenirs from the core.
In a manner of speaking, yes. It's carrying these chemical fingerprints. And it's not just this one study in isolation. The team also connected their findings to previous research.
Okay.
Earlier studies had found weird anomalies in tungsten isotopes, also in volcanic wax. Tungsten's another element expected to be mostly in the core.
Isotopes, right? Those are like different versions of an element, different atomic weights.
Exactly. They act like unique identifiers, like a postcode for where the material came from. Finding specific tungsten isotopes where they weren't expected was already a clue.
Interesting.
So Dr. Messling said their new data, looking at gold and ruthenium, confirms it. It strongly suggests material is leaking from the core into the mantle. The specific isotopes they found, the patterns, they could really only be explained if the material originated deep, deep down.
So it's like multiple lines of chemical evidence all pointing in the same direction.
Precisely. It strengthens the argument significantly. It paints a picture of Earth's internal structure being much more dynamic, much more interactive than we used to think, not just static layers.
That's a huge shift in thinking, isn't it?
Mm-hmm.
If the core isn't this sealed-off vault, what does that mean for our basic model of the Earth?
It's a fundamental challenge. Professor Matthias Wilbold, also from Göttingen, worked on this study too. And he put it quite directly. He said, our findings not only show that the Earth's core is not as isolated as previously assumed.
Right. Directly challenging that old textbook picture.
Yeah. The old idea was core forms, stays separate, mantle does its thing above it. This study says, no, wait, there's interaction. Core materials are actually migrating slowly up into the mantle.
And maybe even helping build things like Hawaii.
That's the implication. These materials might be contributing to the formation of these massive volcanic structures, these ocean islands. It suggests a slow but constant exchange between the deepest layers.
Just how much material are we talking about? Is it like a tiny trickle or?
Well, Professor Wilbold gave a sense of the scale. He mentioned that these plumes of superheated material rising from the core mantle boundary, the source of islands like Hawaii, involve huge volumes. We're talking several hundreds of quadrillion metric tons of rock.
Quadrillion. That's a one with 15 zeros.
That's the one. It's an almost unimaginable amount of material moving from the boundary layer up to the surface over geological time. It really underscores the massive scale and power of these internal processes.
Hundreds of quadrillion tons. Okay, that's definitely not just a tiny leak. That's profound. So stepping back, what are the biggest geological implications here? For Earth's history, maybe its future?
Well, immediately it changes how we understand volcanoes, especially these deep-rooted hotspot volcanoes like Hawaii. It gives us a clearer picture of their ultimate source.
Okay, that makes sense.
But the implications go much deeper, right back to Earth's early history. If core material is leaking out now, has it always been? It raises big questions.
Like what?
Like, could some of the precious metals we find closer to the surface today, things like gold, have originally been part of the core? Elements that settled deep down billions of years ago but have been slowly working their way back up over geological time.
So the distribution of metals in the crust might be partly influenced by this leakage from the core.
It's a strong possibility this research opens up. It could reshape our understanding of how ore deposits form, how elements got distributed, and generally how the Earth's crust and mantle evolved over billions of years. It adds another layer, quite literally, to the story.
It's like finding a hidden chapter in Earth's autobiography.
That's a good way to put it. And Dr. Messling himself pointed out the transformative nature of this. He said something like, whether these processes we observe today have also been operating in the past remains to be proven, which is, standard scientific caution.
Right.
But he added, our findings open up an entirely new perspective on the evolution of the inner dynamics of our home planet. It's not just tweaking a detail, it's potentially a whole new framework.
A new perspective. And that's really valuable, especially, again, for you listening who might be studying this stuff. It's not just memorizing layers anymore. It's about understanding a dynamic, interconnected system.
Absolutely. It suggests material movement between core, mantle, and surface is a much more complex and ongoing story than we realized.
Okay, so let's try to wrap this up. The big takeaway here seems to be that our planet's heart, the core, isn't as isolated as we thought. It's more dynamic, more connected to the layers above. And incredibly, precious metals like gold seem to be making this epic journey from the core, potentially all the way up to the surface through processes like volcanism.
Yeah, a slow journey over millions, maybe billions of years, but a journey nonetheless.
It really changes the picture. And it leaves you wondering, doesn't it?
Right.
If this fundamental assumption about the core being sealed off is wrong, what else might we discover?
Exactly. What other seemingly impossible geological processes could be happening deep beneath us that we just haven't found the evidence for yet?
Could it change how we look for resources in the future? Maybe even how we understand planet formation elsewhere in the universe.
These are the kinds of big questions this research sparks. It really pushes the boundaries of our understanding.
Well, this has been absolutely fascinating, a real journey into the Earth's hidden depths. Thank you for joining us on this deep dive. We really hope it's given you some food for thought, maybe a new appreciation for the dynamic planet beneath our feet. If you found this exploration interesting, please do give it a like and subscribe for more deep dives into science, current affairs, and all the things shaping our world. And definitely leave your comments below. Any questions, thoughts, ideas sparked by this, we want to hear them. Your engagement really helps keep this conversation going, which is so important, whether you're studying for exams or just curious about the universe. Until next time, keep exploring.